Okay. So in today's seminar, what we're going to be covering is major focus is going to be on unit mass data. However, the accurate mass data is also discussed. A majority of the topics that we covered today are going to be applicable to both our unit mass data as well as our accurate mass systems. Then features available by MS and MS data are also going to be discussed. So it's up to you to kind of figure out which ones are applicable to your type of data systems. Remember, single quads are low resolution as well as the triple quad. Triple quads give you the advantage of doing MS data. Then we have our TOF, which is high resolution data, and then we have our QTOF, which is a combination of high resolution data and also MS data. Okay, let's just review real quickly the three major views that we have in MassHunter: the batch at a glance view, the method editor, which allows us to edit the quantitation database, the target ions, the qualifiers, integration parameters, and so forth. And then we have another view of compounds at a glance. And then we're going to also just go over briefly those features unique to handling MS type data from your triple quad and QTOF, and then also handling our accurate mass data. Okay, here's a batch at a glance view. This is the default view that we see in the MassHunter software, and basically where we have information about the compounds and the samples that we've run. In the lower left-hand corner, by default, we have the compound information window. This is the graphics display of our target ion, our qualifier ions, and then our internal standard target, and then our internal standard. And then in the lower right-hand corner, by default, is the calibration curve. The calibration curve is just that. It contains the information of the data points that are in the cal curve that we're looking at there. Okay, and then we also have the method editor view. We get into the method editor one of two ways. We can come over to the method menu item in the batch at a glance view, hit the edit button, steps us into the method editor, or we have our choice to hit the F10 key. The method editor is composed of the method table, which has information about the target ions, again, what transitions we're using, if we're using triple quad or QTOF data. Also, we have a sample information window, which allows us to visualize the chromatogram. As we highlight various compounds in the method table, they can be highlighted in the sample information in an alternate color. In this case, it's green. Then also, in the method editor, we have the ability to look at the compound information window. The compound information window is similar to what we saw in the batch at a glance view. In addition to that, in this particular example, I've also brought up the mass spectrum here for that particular peak that is highlighted in the method table, highlighted in the sample information window, and also illustrated right here. Okay, and then the third view that we have is compounds at a glance. Compounds at a glance allows us to set up, and we'll have look at this more closely later on in this session, allows us to set up for viewing multiple compounds and samples at the same time, the graphics. Compounds at a glance gives us the ability to go through and review large amounts of data in a very quick, efficient fashion. Then to make here is editing quant method. When we're using high-resolution data, whether it be from a TOF or a QTOF, what we need to do is come into our method, edit, advanced tasks on the left, and then mass extraction setup. This allows us to select the mass that we're looking at, but also the extraction window around that mass. How many ppm, Thompsons, or percent do we want to extract that exact mass around? Okay, so we have various, most typically if you're in TOF type data or high resolution data, we'll be selecting ppms for our mass extraction Windows units. And then also for QTOF data and triple quad data, we have the ability to, we're looking at precursor ions and product ions. Basically, this winds up being the same window in the method editor, but when we're selecting our ions, we want to fill in the precursor field, the product ion field, and then the transition field will automatically populate. So keep that in mind. Okay, let's start with today's work after review there, batch table navigation. Okay, I've come in and I've looked at my data here and I've reviewed it. Now, or I'm in the process of reviewing it. I have some ways to move through the samples. I have the green up and down arrows in the batch table. I also can do compounds with the left and right blue arrows, scrolling through those. In addition to that, I also have a bunch of hotkeys that are available to me. Next sample, alt up, previous sample, alt key, plus up, down arrows, and so forth. And then we can also bring in the compound drop-down list as illustrated here and select a compound in there. One of the questions that comes up very frequently is the compound list. You know, by default, it's set up by retention times. Sometimes it's much easier. For example, here, if I wanted to find carbon disulfide, rather than having to remember it comes out at 2 minutes or whatever retention time it comes out at, it may be easier for me to alphabetize those. So the way I would handle that is in the batch table, I right-click, bring up the context menu, and I come over to Arrange Compounds By. And if I select Name, I will get the alphabetical order. Retention time, what comes up by default. I can also view compounds based on their mass. I can look at them in internal standards. I can also view those compounds by compound group, an ID code if I put it in, or any other user-defined variables if I select and use those. Okay, in the batch table, we also have the ability, we have messages and outliers. Okay, outliers are generally highlighted if they're above the limit in red, if they're below a preset limit as an outlier in blue. In addition to that, over on the left side, we have two columns. The first column gives us the quantitation messages. These quantitation messages tell us information about that particular sample and what criteria was not met. For example, with the dibromomethane here, it's looking for a qualifier of 93. The qualifier peak was not found or does not exist in this particular sample. Then we also have in the second column in our batch table the pennant flags. These allow us to look at the outliers and find out what is wrong with the outlier or why it was flagged as an outlier. In this example, the dichlorofluoromethane, retention time 4.6 minutes, was outside the accepted range. We can also come into the batch table and hover our mouse over a given outlier, and it will tell us what that outlier is and what criteria was not met. In addition to that, on the batch table, we have these pennants or flags over to the right side. If you hover your mouse over these, you can select outliers that you want to display. No outliers, high and low outliers, and so forth. You just hover your mouse. We can also view all samples that had no outliers. Typically, those samples will not require further review, so I may just want to look at my samples that have outlier and then make some sort of determination as to why that outlier is there. Also, in the batch table, we have the ability to add and remove columns. Add and remove columns gives us a lot of additional information about that sample. For example, in an earlier slide, I mentioned that we could look at the quantitation message. Well, if you didn't want to hover over the flag and you wanted to see that quantitation message, that can also be displayed right here in this main batch table view. We can also, when we go in and we right-click in the batch table, we say add and remove columns. The first thing that you have to do really is select the correct table. Certain variables here are related to the sample. Others are related to compound method, compound results. So you have to pick the criteria. And if you're in doubt, just scroll through them and look for the variable in these various sections here that are available. So if you're going to add and remove columns, always remember to try to pick the columns, the group that they're related to. Okay, batch table layout modifications, just real simply here, we can look at single compounds in the single compound mode. We can also look at what's called the flat table, which is compounds across the top, and we'll see some other examples of this a little later. And we also have the multi-compound view. If we select the multi-compound view, essentially our samples, all the compounds are listed, and a horizontal scroll bar appears at the bottom, allowing us to scroll through large lists of compounds. Okay, we also have the compound table view. Some people prefer to have the compound table where the compounds are listed on the y-axis or on the left side versus the flat table where our compounds were across the top. We have either view, and the way to get there is right-click, flat table, or compound table, depending upon your personal preference on how you like to view the compounds and how you want to go through your analysis or your review of the data. We also have another concept. Okay, compound groups can be useful to organize a batch table. Okay, we can use compound groups, say for example that we have a parent compound and we want to look at just the metabolites related to those. We also have groups where, another example, say we want to look at hydrocarbons in group 1, aromatics in group 2, and so forth. Okay. The way we would do this is the compound groups are all generated in the method editor. What we need to do in the method editor is to bring up another field for doing that. Before going on into that, compound groups, if I want to look at compound groups, what I recommend doing is just to the right of these outlier flags that we have on the toolbar in the batch table or in the batch view, right-click and turn on the filtering. Then we get a new toolbar comes on into the system, which allows us to look at compound groups. And in this example, I have grouped my compounds in the method editor as group 1, group 2, 3, 4, 5. And then we also have sample groups, which we'll discuss in a few seconds here. Sample groups, okay, can be assigned in the batch table. For example, I would bring up a new column in my batch table called sample group. Then once I have that, I can assign individual samples groups or samples to a given group. This is particularly useful, say you have a bunch of samples that you're running for a customer or client of yours, and some of them want just certain compounds reported, others want other compounds reported, and some may also want all the compounds reported. Those particular people would then become part, those people that want all the compounds reported would become part of the group 1, 2, 2, 3, and then all the compounds would be reported there. Okay, in the batch table, we also have the ability to change the number of decimal places. Well, how do I change the decimal places? Okay, I come over to my Tools menu item. Number formats brings up the formats window, and essentially I would go through, look for the particular variable or parameter that I want to change, and I can change those decimal places. I can change them in exponential form, if so desired, a fixed point, or just a general floating type point. I can also alter my date and time formats here, and then once I say apply, it would change the concentration to 1 decimal place, as illustrated in this example. Calculated concentration is now 1 decimal place. Fixed point, 1 decimal place. Also, another new feature in Quant B.08 that I have available to me is to change the font size. If I right-click in my batch table and go down to Properties in the context menu, I can change the font size, the color scheme. I have several different color schemes that I could look at. The standard one, classical, light gray, black, pear. So we have lots of different options there if you wanted to modify that color. You can do it for day-to-day to put variations in the job. Okay, I have the batch table. I can export my batch table. Now this could be considered the fourth method or fourth way to generate reports. If you remember from last week, we had the ability to generate our reports using Excel, using PDF reporting, and also using new in B.08 Quant, the PDF report builder. So I have all these options. Export the batch table. What this is a popular option that we have to generate Excel-based reports. The way I would activate this is from the File menu item, Export the table, and then it prompts me for a table name. Now in Quant B.08, I have the option to export the entire table or selected rows. And then I also have, I like to turn this on, open the exported file. And the files that I can generate here are CSV, Excel, tab delimited, and XML files. These can then be imported into other applications depending upon how you want to approach this. The key point here is that everything you see in the batch table, any columns that you have there, any layouts that you have for the batch table, you get the exact same thing in the Excel spreadsheet. It's what you see is what you get. So whatever in the batch table, columns and rows and so forth, is what you're going to see in the Excel spreadsheet. Okay, having gone over some of this, let's take a few minutes here for some questions or something along those lines. And Howard, do you have a demo for this for us right now?
Yep, sure do. Got a few things we can look at here. So let me just get that pulled up for everyone. And again, since you'll be viewing a desktop, I'll remind you that you can maximize your view there in the WebEx to make things a little bit bigger, a little bit easier to see. Okay, so here you can see my desktop again, and I want to again go over and show everyone and remind everyone of this restore user setting. It's a great way, again, if you kind of want to start fresh and clean with Quant. And again, I keep it out on my desktop. If you haven't put it there, it's under the Agilent MassHunter Quant, and then quantitative analysis tools, and the restore user settings. Okay, and we just say yes, and it gets us back kind of like as if we just installed it, resets a lot of the default directories in places where it's looking. And again, we're going to be sticking with that same MRM batch that we were looking at last week. And again, I kind of like using that for examples and excuse me, practicing with. It's just real easy data to get around in Quant in before you get on to some of the other different types of data. So here again is our default view once we launch. I'm going to this week open a batch because I've got my results from last week. Come in under triple, and this was a set we were looking at, and there we can see the batch that I had last week. And open it up, and excuse me, everything's there, just like we left it, all our results. We've got, again, you can see this is our default table view for where we've got our samples coming down here in rows, and we've got a single compound view here with several different columns here. We can look at the calculated results, some information on each individual internal standard for the compounds. Again, we can then cycle through the compounds. Steve was saying with these blue arrows, nice way to kind of step through. Same thing with the samples. We've got our green arrows, or we can simply click down into the table, at least in this view for browsing samples. We want to go quickly to one. Now, again, this is a fairly simple batch. Like I said, another nice good one to practice with because of that. We can go directly to any compound. Changing the order of those, Steve had mentioned, if we come out here in an open area of the batch table and just right-click, we can arrange our compounds. You can see by default we're retention time. We switch to name. Then if I come back to this list, we're alphabetized here. Okay, so that can be helpful, certainly with longer lists. And you've got other options, you know, to suit whatever review needs or whatever your particular preferences are for viewing the samples. Couple of the different ways we can look at the tables. Again, nice, quick, and easy. We've got our icons up here. We can go, instead of looking at sample-based, we can go to a compound-based view, okay, where the compounds then become our rows. And now we're looking at one sample at a time, okay? And again, we can cycle through our samples this way with this green arrow, okay? The other option we have is, instead of looking at just one compound here in the columns, we can then go to a multiple view. So now we've got a nice little table here with just our samples that we ran coming down here. And then our compounds are 4 compounds across the top. And again, clicking in any of these, you can see it's changing the view down here. We'll talk about these windows a little more today, later in the presentation, but you can see we can just click through here to quickly view different parts of things. The last view, if you want, again, kind of mixing all these options around, we can go back to compounds in our rows and then kind of a sample summary in our columns. So lots of different ways to look at things depending on your particular needs and preferences. The outliers are kind of a nice feature. You can see here for this particular compound, we've got a few outliers. Hovering shows us why it's showing that as being a high outlier in the red. Retention time's a little further out than it would expect for that. Well, in that one's particular blank, probably not there anyway, just latching on to something. We've got a couple of blue outliers. Okay, this is a little below where it's expecting to see that standard. Okay, so probably something we want to dig into there. The filters here are nice. Again, we can look to see things with any outliers, high or low. Only the high ones, which these also have some low results as well. Same if we go just with the low, or if we want to see our, in this case, since we're looking at a kind of a sample run-based view, we see all the runs that do not have any outliers, and we can go back to seeing all samples there. Okay. Another nice feature that was recently added, like we were talking about number formatting. Just show you that, because at first the format here can be a little intimidating. All the different columns are grouped, and we can open up this window so you can see more of them, broken down into different categories, concentration, different general amounts, things of that nature. Just as an example, say I don't want to see the concentration out in the 4 decimal places for everything. We can go ahead and I'm going to change those just to 2. So I want to find the calculated constant, the final concentration, which we'll talk a little more about the differences between those later. And then my expected concentration, which is going to be my standard concentration there, right here. Okay, and as we change those, we can just hit the apply button and see that kind of tightens up those columns a little bit. Okay. Another thing, adding columns. Let's go back to this view. a nice little summary view here for the for each of my sample runs. One column, we've got retention time, we've got a concentration, we've got the accuracy for that for our standards and our QCs. Okay, so there's our accuracy numbers. One other thing, might be interested in see the raw area counts. If I right-click over here in one of my result things and then go to the Add Remove Columns, area is one of my choices. I can simply double-click, or you can select and then add. We've also got the Remove, Add All, Remove All buttons. So then if I say OK now I can see my area has been added. Maybe I don't like it over here. Another nice thing is I can take and click and drag this around, again, within its particular subgroup, if you will. So this area would only apply to the cocaine results, so it's not going to let me drag it out here. But if I wanted that over by my retention time, I could just simply do that there. If I wanted to do it for all of them, it'd actually be a little more convenient just to come back here and we can sort. So I'm going to move the area up so that I've got it by my retention time, and then that changes for all of them. So if this is kind of a summary that I would like to do, maybe not take the time to do a report template or don't need anything that elaborate, again, this is a perfect place to try doing a export of the batch table, because we can export this right out to Excel now that we've got it set up here. So I can just go File, Export, Export Table. And we can select, I'm going to do it as an Excel, and just give it a name here. And save, and I've already got the open exported file. I'm doing the entire table in this case. And then once that's done, it launches Excel, and you can see we've got a pretty nice right into Excel of what we've got in our batch table. We can go to manipulate this further if we want, send it around for other folks to see. Okay.
All right, thank you, Howard. In fact, we do have a question, although this, Steve, might be more for you, since this was asked a little bit earlier on. How do you designate a target value for QC so that you can see the accuracy or outliers for those QC samples? Okay.
You would treat a QC, in this case, as you would a standard or a calibrator. The QC, in this particular question, would become a point on the calibration curve. It would have an expected concentration, and it would also be labeled as a QC in the batch table. For example, Howard, while we're still on your screen here, you'll notice in his example we have two QCs. We have one labeled L2, meaning it's at the same concentration as our L2 calibrator. The QCs can also be at another concentration. And likewise, in this example here where Howard is right now, we have another QC that's the same concentration as our L4 level, and they're designated. You'll also notice, and getting ahead of ourselves here a little bit, but the QCs then became blue triangles on the calibration curve, and we'll see this coming up in the next section here. Okay, and there's, well, it's up to the right, Howard. You see a blue triangle.
Yep, there's
we zoom in. Right. There's our blue triangle. Yep. Okay.
And there, like we're talking about the accuracy, so that again, this one in particular, this one is being flagged for being a little on the low side. So again, kind of a
well, Howard, what
little visual reminder there.
Yeah. What is accuracy defined at? Accuracy comes up as a default column here in the batch table. And all that accuracy is, you'll notice it's only available for our standards and our QCs. And accuracy is just defined as the expected concentration, i.e. that concentration that we filled in for the calibrators and the QCs, over the calculated concentration as it was calculated from the calibration curve. Ideally, we would want all of these numbers to be 100% or 100. And basically, as these values fall out, low or high, it gives us the criteria for investigating the calibration curve and how well our data, our calibrators and QCs, are fitting that calibration curve. So the accuracy is nothing more than expected concentration over the calculated concentration from the calibration curve.
Okay, thank you. We do have a few more questions here. Are you guys okay to handle a couple more before we keep going?
Sure.
Okay, great. And also, for those of you who've dialed into the phone, you can just speak with us directly. In fact, Alan, do we have anybody that's pressed *1 at this point?
No questions at this time.
Okay, but for those of you on the phone, if you just want to speak with us directly, you can do that. You can hit *1. Okay, the next question in the queue. When you add or remove columns to the batch table, is there a setting name to add the number of calibrators used? This number appears on the calibration curve graphic, but I don't know if it's possible to add this to the table.
Okay, if I understand the question correctly, we want to designate the calibrators.
Or the number of calibrators, I think.
Yeah, it says here when you add or remove columns to the batch table, is there a setting name to add the number of calibrators used? This number appears on the calibration curve graphic, but I don't know if it's possible to add this to the table.
Right, level used points. Yeah, I think it's
right
these
now. Yeah. I don't think we have a way to do that. Put the number of calibrators in there.
Yeah,
okay.
There's not really a subheading that would fall under, since it's part of it's information for the calibration curve, but it wouldn't really fall under like a specific compound or again in a sample-based table. Yeah, not seen that option. Yeah.
Lindsay, let's make a note of this. It's a very good question. Let us investigate this, and we'll get back to the question
user
there and address that later. Yeah.
Absolutely. And if I also didn't articulate that question properly to this person, please ask us another, and we'll dig further either on this webinar or after the fact. Okay. Can you rename a user-defined column in MassHunter?
Yes. We have several ways to name the user-defined. It's a column that's available. We can also put user-defined information in our sequence or our work list in the acquisition modes. Okay, and that user-defined variable would then track into the batch table. In fact, we have up to, if I remember correctly, 9 or 10 user-defined columns that we can define within the batch, allowing us to pull or extract different information out of different samples. Okay.
Okay. Can you please give some examples of how custom calculations can be used with reports and or the table export?
Okay. Custom calculations, are going to require some additional information, a little bit beyond the scope of where we are in this particular lecture here. Okay, custom calculations. If we're going to write up a custom calculation, we're going to need to designate that calculation, and generally speaking, these are in Python code. Last week we talked about the outlier custom calculation. And to go into that, you would need to write a little script that would do the custom calculation. The other option that you have for doing custom calculations is to export the batch table into an Excel spreadsheet and then set up some Excel macros to then do that custom calculation within the Excel environment. So either one would work for us. In Quant B.08, we have what's called the Software Development Kit. The Software Development Kit allows us to develop these scripts or these customized calculations. There's a series of one manual and a series of videos on how to use the SDK, the Software Development Kit, which was added to the Quant B.08 package. Okay, I hope I answered that question. If not, we'll take that one offline and address it a little bit more.
Sure. And I do have one more question, and then we will, we'll check the phone lines one last time. Alan, anybody that's pressed star 1?
No questions over the phone lines.
Okay, and the last question before we keep going, although don't worry, for those of you who've asked more questions, we will stop for 3 or 4 more question and answer periods, so don't feel that we're ignoring you. But the last question here, what is the difference between area and average, I think it's COR.RESP. So the difference between area and average COR.RESP. I'm assuming it's correlation something or another.
Okay, it's correlated response. All right.
Thank you.
We have several ways to do the quantitation in MassHunter software. One of the ways to do that is with average of response factors, and that is where the correlated response comes in there. Okay, generally speaking, okay, area is the integrated area that the algorithms, the integration algorithm found under the peak, and most cases that will be synonymous or the same as the response column in the batch table. Okay, so generally we just view one of those there. Correlated comes up, and I think we're going to address this again offline, Lindsay, because it is a little bit of a complicated answer involved.
Response?
In
Sure.
Yes.
Absolutely. Howard, did you have any other items to share?
No, I was just showing that, as Steve mentioned, the response in the area, like that, typically that's going to be the same once you have that view up. In that other table, the response wasn't a column, but yeah, we can fully answer that offline.
Absolutely.
Yeah.